again. I'm gonna try another day of this Advent of Code. I wanted to try a live stream today, but I set up Streamlabs and it wouldn't capture my main monitor and was not really working. So I felt that I can't spend all day setting that up, so I'll just do a screen recording again, but that's why I'm on my computer instead of my iPad today, and maybe I will do it here instead. I got a question yesterday as well about my setup, so while I'm doing this, I guess I'm gonna talk a little bit about my setup for development. So anyway, let's get started. So day 2, Cube Conundrum. Let's read through it together. So you're launched high into the atmosphere. The apex of your trajectory just barely reaches the surface of a large island floating in the sky. You gently land in a fluffy pile of leaves. It's quite cold, but you don't see much snow. An elf runs over to greet you. The elf explains that you've arrived at Snow Island and apologizes for the lack of snow. He'll be happy to explain the situation, but it's a bit of a walk, so you have some time. They don't get many visitors up here. Would you like to play a game in the meantime? As you walk, the elf shows you a small bag and some cubes which are either red, green or blue. Each time you play this game, he will hide a secret number of cubes of each color in the bag. And your goal is to figure out information about the number of cubes. To get information, once the bag has been loaded with cubes, the elf will reach into the bag. Grab a handful of random cubes, show them to you, and then put them back in the bag. He'll do this a few times per game. You'll play several games and record the information from each game. Your puzzle input. Each game is listed with its ID number, like 11 in the game 11. Followed by a semicolon separated list of subsets of cubes that were revealed from the bag, like 3 red, 5 green and 4 blue. So the format will be game number colon and then a comma separated list of the number of cubes of each color. For example, the record of a few games might look like this. Game 1, 3 blue, 4 red, now there's a semicolon as well, so I guess this is 1 game round. 1 red, 2 green, 6 blue, and then 2 green. In game 1, 3 sets of cubes are revealed from the bag and then put back again. Okay, yeah, so this is 1 set, 1 set, and 1 set, 3 sets. The first set is 3 blues and 4 red cubes. The second set is 1 red cube and 2 green cubes and 6 blue cubes. The third set is only 2 green cubes. The elf would like to know which games would have been possible if the game contained only 12 red cubes, 13 green cubes and 14 blue cubes. In the example above, games 1, 2 and 5 would have been possible if the bag had been loaded with that configuration. However, game 3 would have been impossible because at one point the elf showed you 20 red cubes at once. Okay, so basically this is the constraints and we cannot exceed those. Similarly, game 4 would have been impossible because the elf showed you 15 blue cubes. Yes, 15 blue cubes here, so that would not be possible if we only have 14 blue cubes. If you add up the IDs of the games that would have been possible, you get 8. So 1, 2, and 5. Yep, that makes sense. Determine which games would have been possible if the bag had been loaded with only 12 red cubes, 13 green cubes, and 14 blue cubes. So this is the same as mentioned up here. What is the sum of the IDs of those games? Okay. Okay, I forgot to log in as well. Maybe I should do that. Okay, now I'm logged in. That was fast. So now I can actually get my input. So let's start with actually copying the entire description as I always do and put it into my code. So I'm gonna run it from start this day. So I have a make file and I'm just gonna tell you a little bit about my environment as well. So this is Tmux terminal multiplexer running basically 2 panes, one here and one on the side where I can run tests and stuff. This is just a Powerline shell which I've installed configured. I'm using base 16 and the GitHub theme for my color theme of my terminal, and what more, it's CSH like this, and I'm also running CSH to get some nice stuff. So that's my base setup, and then I'm using Vim, or new Vim to be explicit, and to create my days I use a makefile. So basically it's gonna use the current date of the day to create the files, and I have these template files which I start from. So basically I can do this make day. I also have some code to create the Python zip basically, so I can make it self-runnable through that zip, but I'm not gonna use that right now. I used that before. Let's see, is there anything else I should think about? Probably not. So anyway, this is the framework for my day, and oh yeah, I also added some stuff to my Poetry setup. I updated some libraries, so I'm just gonna commit that first. Git add poetry, git add Pine project. I'm also using Tiki to basically navigate my Git diffs from the terminal easier, so you can see what I've done. Git committed -m, sure, updated some dependencies, and I'm gonna add everything else. Git commit -m, sure, set up framework for day 2. So now I'm ready to start. If I run PyTest, I should see, poetry shell. I need to activate my poetry environment. So if I run PyTest, I can see that everything goes through, and it's actually running the boilerplate for day 2 as well now. So let's start it, and let's start with opening day 2 core here, my core file, and add a split so I can run those and have my tests here. Here I'm using fsetf, which is a fuzzy finder, and I've got it integrated with Vim to quickly open files. So okay, day 2, and this was not what I was gonna do. I was gonna copy the description from the day like this, and I need to basically format this so it's within the line, or actually let's just do the paragraphs because I don't want to format this part. I want that to look, let's do it like this. Okay, so there I have the description, and actually today yesterday I actually used a Vim macro to make this a little bit of a nicer data structure, but today I will just use this as a multi-line string, I think. So I'm gonna use that as the sample seed for today. Triple quote. So that's my games. Yeah, I'm a little bit. Yeah, I could dedent this, but whatever. I can just run a strip when I start. I don't have any. Oh, actually, I do have answer, which should be for the test. Let's see, what were we on? This should probably be in game 1. In game 1, blah blah blah. Which would be possible. Game 3. Maybe I should just add some line breaks to keep this a little bit tidier. I've showed you. Let's see here. Maybe I want to manually add some spacing here. So thing like this. Okay, so you add up all the IDs that would have been possible, you get 8. So let's do that then. Okay, so there I have the start of my test. And the input today is gonna be not a tuple but a string. Oh yeah, maybe I need to just update the seed as well. So I'm gonna get my puzzle input, copy this. I'm not gonna care about the line lengths in here. is the raw data. Okay. Well, I'll keep it for now. Puzzle input as the default type. As type string. Oh, this is the wrong file. Okay, let's undo this. It's the 2 seed. Like this. Did I forget to say this undoing? Check the core. Okay, so first let's do something to parse the games. So I guess we should also add this. I guess we'll see when question 2 comes around if this is only relevant, but I think this will be particular for this one. Okay, so puzzle input equals let's do like this. Game strings equals puzzle inputs dot okay. I can notice I have not done this in a while, but I think it's string dot lines to get each line. I guess I can easier just run something like this. Oh yeah, I probably want to strip it first as well. Let's see here. Oh, actually, let's do like this. We can start with split lines. Yep, it's gonna include the first one. Let's see if a strip is enough. Yep, strip is enough. So I guess we're just gonna do a quick strip and split lines. Yep. So then we have the game strings, and one string will look like this. So we probably need to split out. Maybe we should just create a function for this, like def parse games. Puzzle input string, and it's gonna return something. I'm not sure of the data structure right now, so let's just keep it for now. It's basically gonna be like it's gonna be like a list, of course, and this list would be like every game, which could be like a dict, or maybe we will create a class for that later, but let's just do it like this for now. Game, okay, so data equals parse games input. So here we have the game strings, and for each game we want to get basically parse game string let's just say dict for now, and we can improve it later. For now, pass. And let's say return something like this, parse. Actually, we said a list, so let's use a list comprehension instead of a generator expression then. So parse game, yeah, for game in game strings. So the game string should also be, we should always strip any white space after splitting, so let's just split that at a colon, so then we should have like the game info and unpar sets. Basically, we're gonna have a string of all the sets, and I think we can do something like this directly. Let's just see if we have something like game info dot strip unparsed sets equals game, no, let's just game 34, and we don't care about that right now. Nope, cannot do that. So we'll have to do that afterwards, I guess. Too many values to unpack, expect. Oh. Something like that. And then I guess game info dot split on space Then we want the last, basically. Yes. And we want that as an int. Yep. That should work. So let's note the game ID then as game info.split. Oops, should be -1. And cast it as an int. Yeah, this I cannot do. Let's do this here. Oh yeah. Local variable game ID is never used. We skip that for now. Return. I guess we already have this, like ID equals game ID. And we will have the sets, which should be the parsed sets, I guess. So we have the def parse set. Set string, and that will be a dict, which actually will be a string to an int, because it will be the color as the key, right? And number. So it will be coming in something like this, like let's just it's gonna look something like this. So it will be something like this. So we need to split again. Set string dot strip, and we do a split on the comma. Okay. So this will give us a list that will basically look like something like this. 6 red, and we will have a space, and we will have 1 blue, and so on. So now we need to split that again, I guess. So cubes or cube strings. So basically, for all the cube strings, we want to split them as well. We can do this straight away, actually. Something strange here. So, for cube string in this let's just do this for now. Then we want to split those on, and we want to strip, I guess. So that should end up something like this. And now we basically want to build dicts from these, where we want to have the color as the key and the value parsed as an int as the value. So yeah, let's do it like this, do it like a comprehension. So we're gonna have value, it's actually number of cubes, count. Cube count and color. So we have the cube count and color in cube strings, and out we want to get color and cube count. So this will create a dictionary of these cubes. Let's just make sure we don't have any white space in there. Okay, so that's for parsing one set, and we have all the unparsed sets here. So then let's just do this. Sets is equals this parse set for set in maybe game set, just in unparsed sets. we should have our keys like this, and we should actually return the cubes. Don't. Yep. So then I guess we want to calculate the max set, but let's just first see if this works as we expect. So let's add a break point here and run this through a debugger. Yep. Test debugger. Not enough values. How does cube strings look? Set string, cube strings. Oh. Set string is an empty string, so I guess I forgot some kind of strip somewhere. Let's see, the set strings, unparsed sets. Let's add a breakpoint here. Let's see if we can see. Unparsed sets. Oh, this should be split at one of these. Guess I forgot that somewhere. Yep, that looks better. I guess we can do that here. Okay, let's run this again. Did I add? Yeah, I did add another breakpoint. Game strings, unparsed sets. Game strings. Oh yeah. Game ID 1. Looks good. Continue. Let it just parse a few. Let's see. Yes. Parse games. Parse games. I guess I want to go up. How do I? Was a while ago I did this. Yeah, I'm just gonna remove this breakpoint. It's gonna be easier. that looks pretty good. Looks like a decent data structure to work with. Now I guess we need to sum these up into like some kind of max set to know what's like the maximum for a game. Maybe I should just comment out these with the given inputs because that's a lot. Guess this is gonna be more reasonable. Yeah, this is the games we are working with. Let's just work with those for now. Let's just call this max set. So basically we want to reduce all this. Let's just save this in a variable then. Game sets. Game sets. Let's just. I just remembered we probably want to do this like a default dict because let's see here. Or we can just use get. That's fine. Yeah, we want to basically reduce this into one dict with the max value for each. Let's see how we would write that reducer. So the max set equals reduce. I don't. Shell. Python. Reduce. From iter to is import. Reduce. No. Okay. Well, reduce. Func tools at reduce. From. Okay, I can just check. I'm already in the documentation. Why should I look it up in my terminal? Yep. So we have the function first, then the iterable, and an optional initializer. Let's use the default dict int as initializer. From collections import default dict. Max set, let's just see something here. Max set green, I don't remember. Okay, that's gonna be none. Yep, that's giving us 0. So for our reducer we want to call it something reasonable, and what are we doing? We are trying to find the max number max colors. Actually, we should define up the colors in a data structure. We already know those, so colors equals, we know they are green, red, blue, Did I miss anything? Either red, green, or blue. So those are all the valid colors. So we know that we only have to look at those keys, which actually makes this a bit easier. Yep. Oh, we could probably have. No, we don't need that. Okay. Apply two arguments interval from left to right. Left, right is the updated value from the interval. Okay, so item, and both of these are gonna be dict of string and int. It's actually gonna be default dict. And it's gonna return the same thing. Okay. Basically, we can do something like this. Color and max. We're gonna have something there for color in colors. So we're gonna have max of the accumulated color and the item and this is let's do it like this. Find max colors. Max could be a person, but it isn't. And we want to input the game sets. That's why we split that out, and we want a default dict of int. We also want to add some imports, so from collections import default dict. What more? From functools import reduce. Max set. Probably done something wrong here, but let's add this breakpoint back. Needs type annotation. Okay. Like this, I guess. Let's just run it. I probably forgot about something. Some indentation error somewhere. Where is that then? Verify. because I did this. List has no attribute get. Okay, I have messed something up because it's doing this. Game sets. Game sets. Comma. Looks better. Looks better. So green is 2, makes sense. Red is 4, makes sense. Blue is 6, looks good. Maybe I should just do locals. Max set 4, 3, 1, 4, 3, and 1 is the only one there. That's actually just taking this. Okay, I guess this looks good. Okay, so I guess now I could just take the rule set, which is check which games match this. So I'm just gonna create a function for it anyway to make it nice. Def find valid games, and I guess we will do something like this: cube constraint and games. This is gonna be a dict string int. We should probably have a type dict for this. And this is gonna be a list of dict of string. I should have made a type alias so I can set it up as a type dict later. But let's not spend time doing that right now. And I guess this is gonna return a list of the same structure. It's just gonna be shorter. So basically we want to filter. Let's do this with the comprehension instead. Fusing funct tools. I think that looks nicer. So return game for game in games if, and now we want to basically check cube constraint game should be cubes. Yeah, makes sense. It's multiple cubes, so maybe we should rename this as well. Or cube constraints. That sounds better. Okay, check cube constraints. Let's write that function. So you see that I always define the functions above. You don't really need to do this in Python. This is just like me doing it because I am used coding in C. I'm getting a call now, but I don't know how to pause. So maybe I will just do part 1 and then call back. Game. I should just have a bool. Return. Basically want all, and we want basically a cube constraints color to be more than or equal to game color for color in cube constraints. Let's use get in case we're missing this. I don't remember if we set up the game as a default dict. Guess that should be fine. So then I guess we just need to do find valid games of the game ID or the cube constraints, which is green is 13, blue is 14, and maybe we should do them in the correct order just to keep it nice. The autocomplete is messing with me. And data, and I guess valid games is equal do that, and we should just sum up the game IDs. So ID, I guess, game, no ID should always be there. Some game ID for game in valid games, and this is what we should return. Maybe that is enough. More than or equals to between list and int. Cube constraints. Okay, I've done something wrong somewhere. Probably messed up the order. Of course. I'm using the positional order from point-free programming. But that doesn't apply much to Python. Valid games. Let's do that. Please. No, does not look good. Right. Tube constraints should be more than all the color constraints, right? This is actually valid. Blue 15. This is invalid. So this is basically just getting all the games. If check constraints, return all cube constraints of each color is more than or equal to the game color. This is probably returning 0 because it's not finding it in the game or something like that. Let's add a breakpoint here. Right. I forgot. I should check the max set. That's true. Okay, that is not true, I guess. Let's just do this. For now it's not. Or let's just not care for now. Should have used typedits for this. Okay, remove this breakpoint. Okay. So this should pass. I'm actually missing some coverage, I'm not sure what. Or maybe it's, yeah, it's probably this. Yeah, so the test passes. So now if I enable this one, I can enable them both. Now when I run the test, I will probably get the answer if I've done everything right. Let's just remove the breakpoint, and I'm just gonna do part 1 for now because I need to call back. So let's see if I even have time for part 2 today. Okay, right answer, 1 gold star. And what I do now is basically add this value back here so I can refactor my code later if I want to. I'm just gonna read what part 2 is, but I'm not gonna do it for now. Okay, it's too long. Yeah, I'm not gonna read it now. Okay, thank you for watching, and I might upload part 2. I'll see how I do. So I'm back. I barely took a break because I had to skim through this, and then I realized I think we basically almost already solved this with our data structure. It says the elf says they've stopped producing snow because they aren't getting any water. He isn't sure why the water stopped, however he can show you how to get the water source to the water source to check it out for yourself. It's just up ahead. As you continue to walk, the elf passes a second question. In each game you played, what is the fewest numbers of cubes of each color that could have been in the bag to make the game possible? Again, consider examples from earlier. Same examples. In game 1, the player could have been as few as 4 red, 2 green, 6 blues. This is basically our max set. Okay, now I'm getting the call again. Okay. I got another call. I don't remember exactly where I left off, but I think I had just read through the rules. Basically we need to find the max set, and then we need to multiply all the max numbers and then add all those up for all the games. And this time I'm not looking for games filling the constraints. So let's see if we can solve this really quickly. I will input the values later. Actually we have this answer as well, and basically we want to do the same thing here. No, we don't want to find the valid games, but we want the data, and we want to do this multiplication of all the values. So we want to have like not some. Let's just not care about what we should name it for now. So we want let's do this per game, I guess. Def game, let's call it game power, and this is gonna be dict game integer. So we have game.values, and we're gonna reduce that with multiply, which is from operator, right? Yep. Game.values, and we're gonna start with 1. So we have something like that. And actually we just need to do this for every game. Sum it up. So sum game power game for game in data. I think maybe this is enough. From operator import Moodle. Let's see. 2 errors. Can't multiply non-int of type dict, so again, this should be game max set. Two failures, I guess I did something wrong. Yep, this does not look at. Wait, do I even return the correct value? Did I save this? Ah, I did not save it. So I guess this should be the correct answer. If it's this easy. Yeah, that was the correct answer. Okay. Yeah, I can clean this up later, but I guess that was today's puzzle. Thank you for watching.